Thanks for tuning in at Brackies.
Hello everyone and welcome to this video on making a multiplayer FPS in Unity. Today we are going to be adding the first shooting graphics to our game. So we'll be adding a muzzle flash that will display at the end of the barrel of our gun each time we shoot, and that's going to be a very cool looking particle system. And we'll also be adding a hit effect so that we have some sparks bouncing off the wall and some smoke coming from the place that we hit anything. So that's going to look super cool. We are not going to be adding any bullet hole decals or any bullet trails. If that's something you also want to see, leave a comment in the description or visit the Brackies forum to let me know. It's not something that I'm going to add today because it's too much for one video, and also I think we have a lot of gameplay elements that we still need to add. So I don't want to spend too much time working on kind of details if you want. So I think these two are pretty important, the muzzle flash and the hit effect, because they make the gun feel real and it gives some visual feedback on the fact that you're actually shooting and what you're hitting. But that's what we're going to be doing today. Again, if you want to see more, let me know. So without further ado, let's dig right into Unity. And I pretty much haven't touched this project since we left it the last time, where we created our weapon manager. And that's something that we are going to be editing just a bit in this video to allow for syncing this stuff over the network. So the first thing that I want to do is kind of make actually a muzzle flash with a bunch of particle systems that we can play and stop playing whenever we want the muzzle flash to begin and end. And it's pretty much only going to be displayed, or the particle systems are only going to be emitting one single frame at a time. So we are going to set that up. And as a base for this, I'm going to go under standard assets and then particle systems. Again, this is imported by right-clicking, import package, and then choosing particle systems. I'm then going to go under prefabs and select the flare. This is a super cool looking particle system. If we just reset the transform here and drag it up, you can see what it looks like. And you can see that this smoke is also right now going kind of in the wrong direction. But we'll have a look at changing this. Let's do that right now, actually. So this is going to act as the base of our muzzle flash. And the first thing I want to do is delete the sparks. We are not going to be using those in our muzzle flash. And also go ahead and rotate the smoke 90 degrees, I think, along -90 along the X. Nope. Maybe -90 along the Y. That's not it. That's the Z. So let's try that. Okay, so we need to rotate it 90 degrees along the Z. There we go. And so this should be working cool. And this is set to 90. Okay, so that's why. So that one needs to be 0, and we need to change the flare here to 0 there. And now we can rotate the smoke. Okay, so 0 out the flare, 0 out the smoke, and then we should be able to do -90 on the X here. There we go. That was why I was confused. And let's try and bring in our gun graphic so we can kind of see what this looks like in relation to our gun, because you often go ahead and create some cool looking particles and then they're huge compared to what you need. So always have some kind of a reference when dealing with particles. So this is our sci-fi automatic prefab. And let's just drag this over here. Let's go in and find an empty object here, or create an empty object, and we are going to call this the fire point. And that's just going to sit right at the end of our barrel. So let's go over here and drag that up and drag that in. Right there is going to be the fire point, and maybe just a bit out from the gun. Cool. And then we can take our flare and let's drag that under the fire point, and let's rename this to muzzle flash. And we have the smoke prefab there. Good. So whenever we stop and simulate or pause this particle effect, it's also going to do the same to the smoke. That's the cool thing about or nested particle systems in Unity. So that gives us kind of a lot of freedom. And what I want to do here is I want to change the duration to 1 and do the same thing with the smoke. And then I want to under emission, instead of having this at a fixed rate, I'm going to do a burst instead. So down here under bursts, let's set that between 1 and 1. So you can see what that looks like. And with the smoke, again, no rate, but instead a burst between 1 and we could maybe do 2 here to randomize the smoke just a bit. So you can see now it looks like a muzzle flash. We also want to, of course, reset the transform on the muzzle flash here. And again, the smoke is going off in the wrong direction. So let's... Oh, that needed to be 0. Okay, so that's perfect. So now it's going straight up. You will notice there's also a negative gravity modifier on the smoke here. So that's super cool. So if you wanted to kind of give it a bit of direction, you could tilt it over just a tad so it will shoot a bit outwards and then go up. I think that's actually even better. So let's do that. Cool. So now that we have that set up, we can maybe change the size of some of these elements just a bit. So I think the flare itself here is a bit too large. So let's do a start size between 0.3 and 0.6. And also the lifetime to 0.05. We want that to be very short. So you can see it's only one short burst there. And we don't want this to play on awake. That's very important. The simulation space, we want that to be local because this is only displayed very quickly and therefore we want it to snap to the barrel. However, on our smoke, we want the simulation space to be global or world so that when we move around, the smoke doesn't just follow the gun. It will stay where it was created. So the simulation space needs to be world, and we can go in here and maybe bump down the size a bit. So instead of having this random between two curves, let's make it random between two constants, and let's do that between 0.5 and 1 maybe. That's maybe a bit too small, so we can try 0.7 and 0.2. That looks pretty cool, but again, we kind of need to see this in game. I also think the lifetime is way too long, so let's do 1 instead. So you can see it disappears much quicker, and I think we are kind of getting there. So this needs to be a subtle effect. We don't want anything huge. So actually 0.7 and 1 I think is going to do. And yeah. I think that was all the settings I wanted to change. Maybe let's make this just a bit more transparent. So let's go under the start color and just make that a bit more opaque. Cool. So I think this is a really good base to work off, and let's just go ahead and hit apply on this prefab. So the next thing I want to do is actually implement this muzzle flash in game. So to do that, let's add a new component, and this is going to be called weapon graphics, and it's going to sit on our sci-fi automatic graphics. So it's simply going to sit on the weapon graphics. And the cool thing here is we can have a script that is separate from everything else, that stores references to prefabs for graphics we want to spawn in, so that we can have different hit effects and different muzzle flashes for different weapons. And it can also store local references in the hierarchy over here to stuff like the muzzle flash, which we want to enable and disable. So it's much better than searching through the weapon to find something. This way we can position things on the object, and this component here will know what is going on. So in here we simply want, for now, just two variables. We want a public particle system, and this is going to be the muzzle flash, and we also want a public and this is going to be a game object, and that's going to be our hit effect or impact effect, of whatever you want to call it, and it's going to be a prefab, so we are going to put that in there. And we haven't created this yet. That's for later use, and that's pretty much all I want to do here. It just makes sense to group it this way. So let's head back into Unity and see these two variables appear. And let's just fill out the muzzle flash when we are still on that. So let's do that and hit apply. And now we can actually go ahead and delete this weapon from the scene. We are not going to be needing it right now. Next up, let's open our weapon manager in Visual Studio. So you can see I have it here. And you can see that we currently have a reference to our current weapon. That's something that we keep track of. What is the current weapon we have equipped? Well, I kind of want to do the same, but for the weapon graphics. So we can very easily access the graphical elements of our weapon. And I'm also going to be creating this getter, just like we can get the current weapon, which we are utilizing in our shoot script. We also want to be able to get the current graphics. So let's just keep track of that in here. And in order to do that, let's go in and say private weapon graphics, current graphics, and then we want a getter here. So we want to make a public weapon graphics, get current graphics or weapon graphics, whatever you want to do, and that's going to return the current graphics. And under the equip weapon, this is where we want to store this reference. So you can see here that we set up a weapon instance and we set the current weapon up here. Well, after having created this instance, we want to look for the weapon graphics component on that instance. So we'll go weapon or current graphics equals get component of type weapon graphics. And we want to get this component from the weapon instance here. So we spawn in some weapon graphics. We spawn in a weapon and we search on that weapon for the component weapon graphics and we put that into our current graphics. And that's all we are doing here. And because we have no assurance that the weapon we're using actually has this component, we should do a check here in case we forgot to add it. So let's check if current graphics is equal to null. Well, then we want to freak out. Then we want to debug.log error. No weapon graphics component on the weapon object. There we go, and we could also print out the name of the weapon, which we are going to do. So plus weapon ins dot name. There we go. So that's just good practice to do it this way. The next thing is, if you notice down here, we check if we are the local player. And if we are, well, then we want to change the layer of our weapon. We also want to do this with our muzzle flash, and I'm going to show you why. So if we just go under our prefabs here and find the sci-fi automatic and bring it in here, and let's just make the muzzle flash here play on awake. Let's just do that, and again it's set to loop here, so this is what we should be seeing as soon as we spawn it in. Let's just try this for a second and let's disable that gun. What we will see now when we hit play and we go in on the LAN host is that the particle system is playing just fine, but it's not aligned with our gun. And that's kind of weird behavior, you might think, because if we go into the scene, it's right there. It's completely aligned with the gun. It's actually looking really, really great. And the reason why is because we are setting our weapon to be rendered using a different camera. Remember, that's what we set up the last time. We have the normal camera, which renders everything else, and we have the weapon camera, which renders the weapon. And this is positioned differently. It's positioned further out, and it also has a different field of view than the normal camera, and this allows us to control how the weapon looks in here, but that means that if we are drawing the muzzle flash with the other camera, they are going to be unaligned. So we need to make sure that when we spawn this sci-fi automatic gun in, that the layer it's assigned to is weapon, and that all of the children of that object's layer is also weapon. And currently they are not. You can see that only the root object, only the parent game object has the layer weapon assigned. All of the others are just set to default. So that means we need to loop through all of the children and all of the children's children to make sure to set the layer correctly. And we've actually done this before. Remember, in an earlier video, we created a recursive method to do this. So I thought that since we are using these recursive methods more often than I thought we would, and since it's also a good idea to kind of group together reusable code, that we should go ahead and create a new C# script called util, which is short for utility. And in here we'll have different very general methods that are not part of any particular function in the game, but just have some useful generic methods for doing stuff like setting the layer of all game objects in a hierarchy. So let's do that. Let's do exactly that. So we have this public class util, and it's not going to be a mono behavior, but it is going to be using Unity Engine. And what we are going to do here is we are going to make a public static void called set layer recursively. Here, so we'll change it on all objects, and it's called a recursive method because it's self-referring, and therefore it will branch out to process all different things. So let's first off take in a game object, and this is going to be the object we want to change the layer of. And we're also going to have a integer, which is going to be the new layer index. So that's going to be our new layer. And the first thing that we want to do is, because this is a very general method, we want to make sure that obj is not equal to null. So if that is, we want to simply return. If it's not equal to null, well, then we want to set obj.layer equal to the new layer. It's that simple. So now we've changed it for the current object. Then we want to loop through all of the children to this object. So we want to say for each transform child, and let's do an underscore child here, child in obj.transform. So this is going to go through all of the different transform, all of the different children in the object. And for each of those, we want to check if underscore child is equal to null. Again, we want to make sure that we don't get any null references. If it is, we want to simply continue to the next child. That will skip this iteration. If it's not, meaning if we've actually found a child here, we want to set layer recursively and put in child.gameObject and put in the new layer. So what we're doing here is we're looping through all of the children, and we are calling the same method. We're calling this method again. So that will jump up here. Now the object is going to be the child of the previous object, and it's going to be the same layer. We're going to set the layer of that child, and we're going to loop through all of the children of that child. And that means that it will go through and keep on doing this till all children of children of children of children, however many there might be, have been set to this layer. So that is the super cool thing about this recursive method. So now if we go ahead and find our weapon manager here, instead of calling weapon inst or setting weapon inst.layer, we want to now call util.setLayer recursively. And you can see I can just do this without a reference because I marked it as static. And we can set the game object we want to change is weapon inst, and the layer is going to be layer mask.name to layer, and the name of the layer was something like weapon layer name. There we go. So that's just the variable we have up here. So that should set all of the objects. And when we now go ahead and hit play, and hopefully we get no compiler errors, looks like we don't, you can see that the game object or the muzzle flash is now correctly aligned with our game object. You can see just how cool that actually look. Good. So now that we have that set up, we can go ahead and delete this sci-fi automatic. We're not going to be using that. Or actually, that's silly me. Let's just turn off looping, and let's turn off play on awake, and also turn off looping on this, and make sure play on awake is also turned off there. Let's hit apply on that, and now we can go ahead and delete that. We'll bring it in later. So we can go under our weapon manager and just make sure everything here looks good, which it does, and then we can go into our weapon shoot script. And I actually want to change our player shoot script quite a bit, because currently in our code, in our update method here, we are simply checking for input, and if we get some input, we're shooting. But what I want to do in here is I want to differentiate between what happens if we are a local player and if we are not a local player. More specifically, if we are a local player, I want to call a command that will then call a method that is handled on all player shoot scripts or on the player shoot scripts of this game object, but on all clients that will then display this muzzle flash. But in order to do this, I need the player shoot script of this game object to be enabled on all clients. And currently, we are only enabling this player shoot script on the local player. And we're doing that using the player setup. Remember, we added it up here. If we go under player setup, we have the player shoot script right here as one of the components to disable. So that's what I want to delete. Delete that array element. Just right click it, delete the array element, right click it again, and it will remove it from the list here. And then I want to go down into the player shoot and add in some conditionals myself. So the start method, we want this to be done no matter if we are the local player or not. That doesn't matter. In our update method, we want to set the current weapon. Again, that doesn't matter. We want that to be done for all. And then we are calling these different shoot methods. And if we go and look at the shoot method, and this is again going to be called for all clients, we are actually doing some raycasting here. And this is something I want to only do if we are the local player. So I can add in an if statement here saying if we are not the local player, so exclamation mark is local player, well then we want to return. Then we don't want to do all of this down here. But if we are, then we want to do the actual shooting. This allows us to add some stuff to this object, which will be called for all others that are not the local player. So let me give you an example here. Basically what I want to do is I want to create a command. Again, remember, a command is a function that is executed only on the server. So let's make a command here. And this is going to be a void. It's going to say cmd on shoot. And this is going to be called every time we shoot. No matter if we hit something or not, this function is going to be called. And we are of course going to be doing that here. And again, I want this to be below this if statement because we only want to call this command from one place, and that is if we are the local player. This way, the local player will be in charge of when he shoots, not all of the other clients. That's a much better way. So we'll do that. And yeah, so if we are the local player, we want to call the command on shoot. And then in here, we can put some functionality for what we want to happen when we shoot, such as calling a method on all clients that will display a muzzle flash. So let's do that. So remember, when we want to call a method on all of the different clients, we use what is called a client RPC. So when we mark this, it means we can go from the server to all clients. So we put in a void here, and this is going to be called RPC do muzzle flash, or do shoot effect here, and we don't want this to take in any arguments. And this here can refer to different stuff up here. It can refer to variables. So what we want to do here is we want to change the value of our muzzle flash. So we have this command on shoot, and we want that to call the RPC do shoot effect. And I think it's time to comment some of this out. So we are shooting, comma, call the on shoot method on the server. This here is called on the server when a player shoots. Is called on all clients. Is called on all clients when we need to do a shoot effect. And yeah, that should be good. Let me think here for a moment. Good. So the first thing that we could sort of do here is just try and enable our muzzle flash, just to see if this is going through. And in order to do that, we need a reference to that muzzle flash. And again, we have that reference in the weapon graphics, and we have a reference in the weapon graphics in the weapon manager. So if we just go into our player shoot, just as we are getting the current weapon by calling current weapon equals weapon manager.get current weapon every frame, we can do the same with the graphics. So in here, we'll simply say, we'll simply have a private. Actually, instead of doing that every frame here, let's just down here say current, or let's say weapon manager dot get current graphics dot muzzle flash dot play. That is going to play the particle system muzzle flash that we have set up. So this is kind of a long and maybe tedious way to do it, but it's going to get the job done and it's going to work just fine. So let's try this out now. It should happen that when we shoot, the muzzle flash gets enabled. It's not going to get disabled again, but it is going to play. So let's try and play here. And let's select LAN host. And let's try and click. And again, it does get enabled. And you can actually see that it's actually working just fine. I did think that I was going to go ahead and, or going to need to disable it. But since the particle system only emits in bursts, that's actually not something we want. So that's awesome. I thought that we would have to go in here and create an iEnumerator that we call from here a coroutine that would play the particle system, then wait a frame, yield return 0, and then stop the particle system. But since the particle system is so short, Unity does it for us. Okay, so Unity is awesome as always. So let's just stick with this. And again, if it becomes a problem, we'll do what I talked about. Whoops, sorry, accidentally swapped desktops there. Good, so now that we have that done, what we can do is just see if this works on the network. So let's test this out. So let's hop into Unity. Let's build this player here. Simply Control B or Command B if you're on the Mac. And let's see if this works. So I'll just drag this over here and wait for Unity to build the lighting. There we go. Hit play. Let's join here as an host. And let's join here as a client. And you can see here that when I press this, it's indeed networked. And also make sure that when you are pressing or when you're firing here, that the other player doesn't fire. It doesn't look like it. And you're not going to be able to see this, but I'll drag the other one over to the other screen and just make sure that this is working. And indeed it is. So just take my word for that, and that's awesome. So next up, let's do some bullet impact effects. And those look so cool when they're implemented properly. So what we're going to be doing is actually really simple. Most of the scripting for this tutorial is actually over, but we are going to be creating the particles first. So let's go under Standard Assets, Particle System, Script or Prefabs, and find the flare. I think this is a great actually base for a impact effect as well, especially with the awesome spikes here. They're going to look super cool in the game. So again, let's reset this transform, drag it up. Let's take the smoke now, and if we just think about this for a second. So first off, we want this to be again emitted in a very short burst. So let's keep looping on for now because we want to see what this burst looks like. But let's change the duration to 1 and do the same here and the same here. And then we can go under our flare here. Let's rename this to hit particles or hit effect or whatever. Let's go under emission and change the rate from 0 to burst between 1 and 1. That looks good. Let's take the smoke here and again go to emission 0. Let's change the burst here to be between 1 and 3 maybe. Let's take the sparks, go to emission 0, and let's make those go between 0 and 4 maybe. Something like that looks pretty cool. And what we can then do is maybe drag this over to a wall just so we can see what it looks like if it's on a cube. There we go. Let's drag that. Oops, we only dragged the sparks there. I want to take the entire particle effect and drag over and see what this looks like. So it's kind of hard to center in on right now. So the first thing that I kind of want to figure out here is how this is oriented. So, okay, this is being weird. Let's just reset the transform and zoom in on the effect. There we go. And let's just see we hit the floor here. Well, in that case, I want this Z here to be pointing upwards. So I'm going to rotate -90, -90. Oh, -90 on the X. And then we want our smoke to go upwards. So we'll take our smoke here and let's 0 that. There we go. So we hit down and the smoke goes up. And if we take a look at that, that looks just fine. Then next up, we'll find our sparks. And again, we want to 0 that out. And they are currently being emitted if we go and open up shape here in a sphere. Instead, I want those to be emitted in a hemisphere, which is a half sphere. So they will not jump in towards the wall. They will only jump outwards. And that looks very cool, actually. Let's also take the smoke and make that a bit smaller and change the lifetime. So let's set a lifetime of maybe 2 seconds. That's more than plenty. Let's do 1. I think 1 is a bit more manageable. It really depends on the size of the gun that you want the effect to cover. The sparks, the lifetime here is going to be 2. That's fine. And for the hit particles, the lifetime should be very short, so 0.05. The start size of those, I think 0.4 and 0.8 maybe. We want the start size of the smoke to be again, random between 2 constants. And we want that to be between, let's say, 1 and 2.5, or maybe 1 and 2. That looks super cool. And I think actually the size of the sparks are pretty good. We could maybe do 0.02 there. Yeah, I like that quite a lot. So a very subtle but cool looking effect. What I will also do is go ahead and actually create an empty game object, which we will reset the transform of. And we'll call this one hit particles. And then we'll call this one, let's just do flare. And we'll take all of these, put them under hit particles. We'll take those and drag out here. And reset the prefab instance, that's just fine. And then we can find the prefab here and delete, or not delete anything, let's just find the prefab and let's take the hit particles and drag in here. So that we have this object with 3 different particles in it. And this way we can take our flare here, which is too large. I think it should be 0.2 and 0.4 instead, maybe something like that. We can take that and we can drag it out a bit, and that will make sure that it doesn't clip through the ground. You can see if I drag it down here, you can see it does this ugly clipping on the ground. If we just drag it out just a bit, something like this, it's going to look a lot better and no one will really notice. So that's going to make the effect a lot cooler. And I think we should just try this out. So let's hit apply on those hit particles and let's save that. And let's then find our prefabs Sci-Fi Automatic and drag in the hit particles under the hit effect prefab. And that is good. And then we need to spawn it in through code. So let's open Visual Studio. And just as we called the command on shoot, we also want to have a command on hit. So let's just go ahead and make that. And we can just have that down here. We're going to have a command void cmd on hit. And this is going to take in some parameters. First off, a vector 3 for the hit position, and then a vector 3 for the normal of the surface that we hit. And again, a normal is a vector 3 that points straight out from the surface. So it's orthogonal on the surface, meaning that there's a 90-degree angle between the vector that points out from the surface and the surface itself. So yeah, and then we want to call, of course, an RPC. So let's just duplicate this RPC right here. And this one is going to be called RPC do hit effect or impact effect or whatever you want to do. And what we want to do in here, we'll figure out in a second. And this is also going to take in a vector 3 position and a vector 3 normal. Cool. And inside of our command on hit, we'll simply call RPC do hit effect with the position and the normal data. There we go. And then down here, we only want this to be called if we hit something, and that is within this if statement. So if this raycast returns true, we've hit something, and if that is true, we want to call command on hit, and we want to enter in hit.point, the point that our raycast hit, and hit.normal. It will simply return the normal coordinates of that, or the normal vector of that surface. So good, it will call that, and we can just comment this out. We hit something, call the on hit method on the server. And here is called on the server when we hit something, takes in the hit point and the normal of the surface. Cool. And here is called on all clients. Here we can spawn in cool effects. Good. And that's exactly what we are going to do. We are going to instantiate, and then we are going to do weapon manager dot get current graphics dot hit effect prefab. There we go. And we want it to be instantiated at position, and the rotation is going to be quaternion dot look rotation, and then that takes in the vector. So this will transform a direction to look in into a quaternion, which is what Unity uses for rotation. So that will take in the normal surface, and that will make sure that our effects are spawned looking directly out from the surface. So let's say we hit our cube here right on the wall. It's not going to be looking that way or along the wall. It's going to be looking straight out in an arrow. So that's going to look super cool. Good. So now that we have that set up, we're instantiating it in, let's also just store a quick reference to the instantiated object so that we can delete it after, let's say, a second, so we don't clutter up our scene with unnecessary objects. So let's store a hit effect reference, and we want that to be a game object, so we also need to cast it. And then down here we simply say destroy hit effect, and we want to destroy that after 2 seconds. This way we give the effect plenty of time to play, to finish. So that looks super cool, and I think this should be working now. Keep in mind that you are spending quite a lot of resources on instantiating in a hit effect, especially if you have some kind of machine gun and a lot of people are shooting at the same time. If that starts to bother you performance-wise, you should look into object pooling. There are plenty of good tutorials on this on the internet. I might do one myself at some point, but you should definitely be covered. It's a more effective way to kind of spawn in objects. So you should check that out. Again, object pooling, like swimming pool. Good. So now that we have that, let's save that, close that, and first off, try this off locally. And we can see that it's working, but it's also the effects are also looping, and I actually don't think they're oriented correctly. Oh, I might be wrong about that actually. Let's just try and hit something here and pause that. Let's find our hit particles here. And they are actually oriented correctly, it looks like. No, they are not. The sparks here should be pointing outwards. The smoke should be pointing outwards, and the flare, yeah, I was correct about that. Okay, so let's go ahead and find our prefab here and fix those sparks. So let's find our hit particles. So when this hit particle here is pointing upwards, meaning it has a negative X, well then we want our flare to reset there, so that should be pointing upwards. We want this to be reset, so that should be pointing upwards. And we want our sparks to be reset, so those are pointing upwards. And also we need to make sure that we disable looping. Play on awake should be true though. We also want to disable looping here. And we can just make the simulation space local because it's not going to be moving at any time. So let's just spare ourselves the calculations. And let's apply that. Delete that, and let's just try this again. It should look a lot better. There we go. So this looks super cool. Just a very tiny impact effect with a lot of sparks and some smoke, and I think that looks really cool. You will also see in a moment when we test this out on the multiplayer that it also works when we are hitting bots or each other or the players. So let's try and build this and wait for it to build here. And it's going to open up here, and let's wait for Unity to calculate the lighting. Once again, there we go. Let's just save that. And let's try and hit play here. Bring this over. Let's select LAN host on this one and LAN client on this one. And you can see here that other players can see this impact effect as well. So it's synced over the network, and you can see because of my lack of network ping here or delay, that it's actually going really quickly. It's very responsive, and we can also shoot each other, and that actually looks super cool. So look here, we can shoot each other in the face. So, and now I can't because this guy's respawning, and you can see there he became responsive again. So that just looks super awesome, and I think you should go ahead and have a lot of fun with that. Also, if you are having performance issues and you've tried out object pooling, these dynamic sparks, which jump off everything in the environment, those are kind of taxing. They require a lot of physics calculations, so maybe spawn fewer of those in, or maybe make them non-bouncy, meaning that they shouldn't collide with the environment. So that was basically all I wanted to show you for this video. I hope you enjoyed it, and I'll see you in the next one.